Welcome to a new video. This is Mo from MC Master Path, and I'm glad to be presented today. In today's video, we're going to be exploring how you can build your own app to convert different formats of files, PDFs, Office files, images, and other formats into a Markdown format. The Markdown format can then be converted to CSV files, which are going to be quite handy when you are fine-tuning your large language models using the Unsloth method. The tech stack that we're going to be relying on for our application is as follows. We're going to be using Python as the programming language of choice. We're going to be using VSCode as the integrated development environment. We're going to be relying on Streamlit for the front end, and we're going to be using Ollama to use large language models and embedding models locally in our machine. We're going to be splitting this video into a number of parts. The first part is going to be a walkthrough for the app and how it works. The second part is going to be how to install the dependencies and how to put them in place. The third part is going to be explanation of the underlying code for this application. In this section of the video, we're going to be exploring and having a walkthrough of the app itself and what it does and the main features and functionalities. When we run this app through Streamlit service, and as you can see here, on the left there is a sidebar which details the purpose of the app, pros and cons of using the app, main features, how to use it, some contact details, the license itself, and then the version control. The app itself is composed of three main tabs. The first tab is to enable the end user to convert from a wide variety of file types into Markdown format, which is .md. The second tab is to enable the end user to convert a Markdown file into a CSV file composed of questions and answers. The third tab is to enable the end user to skip the part of the Markdown and then convert directly from the main file format into a CSV file which contains questions and answers. So let's start with the first tab. The first tab, you can upload the file, whatever file you want. The file that I'm trying to upload, it's a PDF which contains the RICS APC summary of experience. That was my file ages ago. It contains different areas of competence alongside a wide variety of them paragraphs concerning these areas of competence. And I want to convert it to an MD. It's one file, which is file6.pdf, and I want it to be into one Markdown file, single file. And I don't want to have any large language model that is used for the conversion. I just want to rely only on MarkItDown library. And then I press on convert to Markdown. It's going to take a little bit of time. It is instantaneous, and then you can see the amazing work or amazing result that it has done, and that is going to be quite easy to tweak into a Markdown file, and then you can download the file however you want. We can also try the other option, which is use large language models for enhanced conversion. When I press on that checkbox, it's going to give me a drop down list which contains a number of the models that I've downloaded from Ollama.com. I can choose the QWQ, which is the best model up till now. In terms of reasoning, it's open source. It's about 20 gigabytes, which should fit in my RTX 3090, and then I can press on convert to Markdown. It's going to take a bit more time than the previous result. I've done the same job. Absolutely fantastic. The file is quite easy and straightforward. I think there are some bits and pieces that might need to be deleted in the file, such as draft not for assessment, which is, as you can see here, it's the watermark. When you press on the second tab, which is Markdown to CSV, I have got already that Markdown file. I could convert it into CSV using the second option because I haven't done the question answer correction within that file. So I'll opt in to use generate Q&A pairs using LLM. So I've chosen that file, and then I'm going to be clicking on convert to CSV, which should provide me with questions and answers. I've waited for a bit of time because that model is a bit large, because it's a 20 gigabyte model, 32 billion parameter model, and it provided me with questions and answers. It's fairly straightforward. It had generated about 78 questions from that specific file. The answers to it, they are basically correct, but I would have preferred to have done it manually because I could control the quality of the output itself. But manually, when it comes to a huge amount of files, it's going to take ages. So this result is satisfactory. It can enable the end user to understand how they could play in the realm of answering RICS APC questions, and also it can widen the imagination of the end user or the RICS APC candidate, as well as enriching them in terms of knowledge. The third tab is all about the direct conversion from the file itself to questions and answers. As you could find here, there is a wide variety of files that could be converted. I'm just going to be sticking with that PDF for the time being, and as you can see here, there are two options for choices. You can select the large language model as you see fit. I have downloaded a number of them large language models. Large language models available do not include any embedding models. The embedding models are here. I've downloaded 3 of them, all many LM, Nomad embed text, and mixed breed AI embedding large. Once the end user selects both of them models, the large language model itself and the embedding, they can click on browse, and then they can go to the folder where the files are sat, select any file, and then they can press on generate Q&A pairs. I have done that job for that file, and it generated a fair number of questions in here, about 99 of them. And again, that is echoing what we have said in the previous tab. The questions and answers might seem a bit summarized, and if I'm going to be preparing the data for an organizational purpose, I would have preferred to do the job a bit manually, because I could have controlled what are the areas, what are the levels inside each area of competence, and I would have anonymized and pseudonymized the responses according to the needs in order to reduce the bias. The reason behind using CSV files is that they're super easy to deal with when it comes to fine-tuning large language models using Unsloth. I've prepared another video of how to use Unsloth to fine-tune large language models using CSV files and using the conversational chat templates provided by Unsloth. So I'm not going to be discussing the full context of the fine-tuning in this video. However, I'm going to be focusing on a very specific part, which is changing one format of files to another, starting with CSV files. In Unsloth, after you install the dependencies and then you import whatever model that you see fit and identify the sequence length depending on your GPU, it's now time to import the CSV files and convert them to a shared GPT format in this way. So the shared GPT format starts with a system. You have here a generic description about what's happening behind the scenes, a human, which is the actual question, and the answer, which is going to be provided by the GPT itself. And what I did here was import the CSV file, add column called train, because the data that I did possess was for training only, and then I added a column called conversations with the compiled questions and answers in the shared GPT format. And then I removed any unnecessary columns, and I'm printing here the pandas data frame after being converted into a shared GPT format. Having done this, we need to convert into Hugging Face format. So instead of human and GPT, it's going to be user and assistant, but the same context, as you can see here. Once we have done the Hugging Face format, we're going to be converting into a chat template for Llama 3.1 that is provided by the Unsloth team. And the chat template for the Unsloth Llama 3.1 model is looking like this. So we're going to be beginning the text, and then there is a header and what the user is going to be asking about, and then the end of header ID, and then the actual question, and then end it with end of token ID. And that's quite important so that the model is not going to be generating text endlessly. If you missed the end of token ID, the Unsloth documentation say that the model is going to be generating text endlessly. And then we need to specify the answer. So start header ID, and then what the assistant is going to be answering with, and end of header ID, and then the actual answer. And then again, we have to add the end of token ID so that the model is not answering endlessly. The Unsloth team, they have specified that we have to do this twice. So we have to provide 2 users. So the user and the question and the answer, and then the user saying that's great, thanks, or whatever you want really, and then end of token ID. And that's exactly what we're doing here. We are importing chat templates, specifically the Llama 3.1 chat template. We are creating a function to convert the conversations using the chat template itself, and then we are using a library called datasets in order to convert the pandas data frame into a format called arrow datasets, and then we are applying the chat template to that pandas data frame, taking into account the formatting function. And as you can see here, that's the Hugging Face data, where we have the system, user, and assistant. That's the generic description of what's going to happen behind the scenes. That's the actual question, and that's the actual answer. And here is the converted into the Llama 3.1 chat template. So it has to state what is the cutting off date of the knowledge that is generic. It's going to be starting with the generic description of what's going to happen behind the scenes, and then end of token ID, and then it's going to start with the actual question, give me a good quality example of whatever, and then it's going to respond starting from here, which is the assistant. That's what we're going to be after. The tech stack for our video today is fairly simple. we need the programming language. Our programming language of choice is Python. You need to download a version that is newer than or equal to 3.10. You can go to python.org/downloads/. Based on today's date, which is January 2025, you'll find version 3.13.1, which you can download. The second element that we need is an integrated development environment, and our integrated development environment of choice is VSCode. It's available for all the operating systems, whether using Windows, Mac or Linux, and you can download it from code.visualstudio.com/download, and you can follow the instructions on the screen. The third item in our tech stack is Ollama. Ollama, it allows dealing with and chatting with large language models locally in our machine. You can go to ollama.com and you can press on download, and then you can download the app itself and follow the instructions on the screen. You can also explore the models on Ollama. Ollama has a wide variety of the models that you can download on your machine. So once you have installed Ollama, you can go to the command prompt and you can type Ollama serve. In my case, Ollama is already serving in this local host, and then you can say Ollama list, and then you'll find all of the models that are installed. When you install it at the first time, you will not find any models. For today's video, we need a couple of the models to be installed. So the first one is going to be Ollama pool and then o-mini LM. I have it already here, as you can see, the latest. And we also need Nomic embed text. So o-mini LM and Nomic embed text are embedding models which are encoded only. They're going to be breaking down the text into chunks and be embedding these chunks into a vector database. The third model that we need is the mixed breed AI embedding model, which is MX, which stands for mixed breed AI-embed-large. Once you have installed these three models, you have the best embedding models on Ollama. We then need at least one large language model of choice. You can download whatever you want. Let's download the Llama 3.2 version. You can write down Ollama pool and then the name of the model and then press enter. It's going to be downloading. And then the last piece of the puzzle is MarkItDown Python library, which is the main core of our today's video. It's a library that is provided and developed by the AutoGen team from Microsoft. And what it does is that it converts a wide variety of the files to Markdown. You can install it simply by pip install MarkItDown. We're going to be installing all of the requirements when I explain the code. And then it has two main usages. You can use it simply, a basic usage here, by importing it in your code and then make the best use of MarkItDown to convert a specific Excel sheet and then showcasing what's the end result. Or you can combine it with a large language model to deal with images or other files, as you can see here, and then provide with the end result. We're going to be showcasing how we can embed the Ollama itself instead of OpenAI, so that you can have vision models and large language models running locally on your machine. The code that we're going to be using in today's video is existing and saved on my GitHub repository, which is called Convert PDF Office Files to Markdown and CSV. You can access this repository by going to github.com/moashore93/ and then the name of the repository. The repository is broken down into a README file with full explanation about the app itself, how it works, what are the prerequisites, and how to install everything in place, and also how to use it. It also digs deeper into the MarkItDown library, which is the core library that is used in this application. It also explores and showcases what is the license and what are the limitations itself, and it gives further details about the contact information for myself. You can scroll up and go to the code itself, and if you click on it, you will see the full code with explanation. On the GitHub repository, there's also a file called requirements.txt, which contains all of them Python libraries that are necessary for our development. I've extracted these requirements.txt file from my current virtual environment, and I'm going to be exploring how we can install it on our machine. Before we start running the code itself, we have to install the requirements. So having installed Python and VS Code, we now need to install the packages. So the first thing that we need to do is create a virtual environment, and there is an easy way to do this. So inside VS Code, you can go and then click on terminal up top and then new terminal, and you can type in Python 3-m virtual environment, which is venv, and then the name of the environment. You can call it however you want. For me, I just called it MarkItDown. Let's call env, and then you can press enter. For me, I've already created it, as you can see here on the left. you will see that it's called MarkItDown_env. We now need to activate it. It can be easily activated using the name of the environment itself. In my case, it's MarkItDown_env and then /scripts/activate. That is on Windows. You will see on the left that it's now activated. When you clone my GitHub repository or just even download the Python and the txt file for the requirements, make sure that you open the terminal inside the folder where it contains these two files, and then you can easily type in pip install -r requirements.txt. This file includes all of them Python libraries and packages and dependencies that are required for this specific project, and then when you press enter, they're going to be installed. It's going to take a bit of time, but not too much time, maybe a minute or two, and everything's going to be installed and going to be up and running and ready for the direct deployment. And now let's explore the code together. As explained, the code itself is exceeding 800 lines, so I'm not going to be going through each and every single line. You can check the GitHub repository, tweak it to benefit it at your own pace. So in order to build this application, it's built using 4 steps. So we're going to be starting with importing the necessary libraries such as Streamlit for the front end, pandas to deal with data frames, MarkItDown, which is the core function that I'm going to be using today, and also we're going to be making the best use of requests and JSON. The next part of our code is integrating Ollama into our system. So in order to do that, I've created 2 formulae. The first one is getting the Ollama model, or providing the end user with an easy way to get Ollama models. I've hard coded the embedding models because I'm well aware of them, and I've only downloaded 3 embedding models. One of them is Mixed Breed AI Embed Large Model, one of them is Nomic from the Nomic team, and the last one is the smallest, which is All Mini Language Model. I then connected to the API local host, which is 11434. It's by default. If you have changed it in your system, you have to change it here. I'm basically giving the end user the freedom to choose whatever model they want. So if they are dealing with language or large language models, they're going to be choosing all of the models except these 3. And if they're going to be choosing embedding models, like in here, available embedding models, they're going to be choosing only these 3. The second function that I've created as well for the Ollama integration is called Ollama client, and that function itself contains 3 other functions: the initialization function based on the chosen model, and the second function is chat completion, because I have to send a request for Ollama with the role and content so that it can provide me with a response back, and I'm doing this in a JSON format, and I am undertaking some error handling. The third and the last function inside the Ollama integration is create embeddings, because I have to create embeddings since I have chosen to have an embedding model for the advanced functionalities. I'm connecting to the API of Ollama, which is local based on my computer, and then I am creating the embeddings array and I'm returning them. And the second step in building this code is building functions that are related to file processing. The first function that I've built is related to the processing of a single file, where the end user will have to upload a file and determine if they would like to use a large language model or not. So I've put in use LLM, which could be true or false, and then if they're going to be using an LLM, then the function itself will be linking to the Ollama localhost, which is 11434, and taking into account the selected model. There are 2 cases here. When the end user selects a large language model, then MarkItDown library is going to be linking to Ollama and using whatever model the end user selects. And if the end user did not tick the checkbox, then the file is going to be converted into Markdown format using just MarkItDown library. The second function that I've created is extraction of question and answer pairs from the Markdown. That is going to be reliant on a Markdown file that is formatted in a way that is correct, where there is a line containing the question and then the next line is containing an answer. So in this case, for every question, there's going to be a question that is added to an array with its own answer, which is identified by having an enter and then there is the answer. The next function that I've created in relation to file processing is the generation of question and answer pairs using large language models. And this function takes the selected model, a chunk size, and we're going to be defining the chunk overlap. The goal of this function is to break down the text into chunks And then based on the chunks and embeddings will have to be created, and the chunking method that we used is taking into account all of the words and trying to create meaningful chunks by understanding what is the word size and putting them into an array. There's quite an interesting part in this function, which is prompt and the example that's given into the large language model. And this part, it identifies how intelligent or how stupid the model is going to be acting. So in my case, I was quite straightforward with the actual task at hand, which is the creation of question and answer pairs and being factual, being explanatory as much as possible and trying not to faff about. And concerning the role of the model itself, the model is going to be acting as questions and answer pair generator. The model is going to be having a degree in civil engineering, working in quantity surveying, working in a consultancy in the UK, having an understanding about the RICS and all of them guidance notes. The end user can then download the code from the GitHub repository and tweak the prompt and the response according to the needs. In my case, I was dealing with construction documents, hence the choice of such responses and rules. At the end of this function, I'm just creating a couple of them error handling procedures to make sense of what's produced, and if there's an error, then it's going to spit it out to the end user. The next function in relation to file processing is process files to questions and answers, and that is related to the third tab, where the end user is going to be identifying the file, choosing the embedding model and choosing the large language model, and then the model is going to be doing all of the trick. So there's going to be embeddings that are generated, question answers in pairs, and then we're going to be making the best use of previous functions that we've created, like generate question answer pairs with LLMs and processing of the files themselves. And then we're going to be showcasing the question answer pairs and the embeddings. And the last function in relation to the file processing is create question answers data frame. And the goal of this is to print everything in a CSV file, or at least build the data frame, the pandas data frame, which is then going to be printed into the CSV file based on an understanding of the embeddings, which are created using the functions above. The last step in building this application is actually building the main application with the 3 tabs and taking into account all of the functions that we have built above. So concerning the format of the application, I've added a sidebar where I'm putting in some important information about the purpose of the application, the limitations, pros and cons of using that application, as well as the licensing requirements and issues. And then I began with the tabs. The first tab is related to the file conversion from its own original format into Markdown. I started by giving the end user the option to upload a wide variety of them formats. The end user can then choose if they want to combine the converted Markdown into one file or generate multiple and separate files depending on how many files were uploaded. The end user can also choose if they want to use a large language model for an enhanced conversion from the original format into a Markdown format. The end user can also choose whatever model they want. If there are no models that can be found, or if there's a problem with the installation of Ollama, or if there's a problem with the local host of 11.434 of Ollama, then an error message is displayed to the end user. And then we're making the best use of the process single file function that we have produced above, where the end user uploads a file, this function receives the file and then accounts for the LLM that is chosen if applicable, and then connects to Ollama using the file that was selected, and then the content is generated in an array. And then the end user will have a combined Markdown file if that's what the end user wants, and then there's a download button for the whole process. And the same goes to separate files. If the end user has uploaded multiple files, these files can be either combined into one file or in separate files. A download option for these separate files is presented to the end user. I then generated or created a second tab, which is relevant to the conversion of the Markdown file into CSV. So the Markdown file could be a clumsy Markdown file from the first step, and here the recommended option would be using a large language model to extract the questions and answers and compile them into a pair. Or if the end user is confident enough to generate their own questions and answers in the Markdown file, then they can upload the cleansed Markdown file, and then this application is intelligent enough to create question and answer pairs from that file. And here I'm giving the end user the option to either upload a cleansed Markdown file with the question answer pairs, or use a clumsy file and then ask LLMs to do the job for them. And then I have two models of choice. The first one is the large language models, excluding the embedding models. And the other thing that the end user is going to be choosing is the embedding models. And in here I have three embedding models, which are basically all many LM, mixed breed AI embed large, and nomic embed text. And then I entered into the option of not using LLMs. So if the end user is going to upload a clean file which contains questions and answers, the code is going to proceed directly with it. And if the user chooses the option of using large language model, then the code is going to be implementing that option. Embeddings are also created for that markdown file if a large language model is chosen. And then the questions and answers alongside the embeddings are going to be put into a data frame, and the end user is going to have the option to download the data with embeddings or the question and answer pairs separately, and that's what I'm doing here. And lastly, there's some error handling that might happen if the file is so clumsy, or if a non-vision language model is chosen for an image, for argument's sake. But in here, because we're dealing with markdown files, so possibly that's not going to happen. But I just put it because error handling is an integral part of any coding process. And then the last piece of that code before the actual deployment or the initialization of the whole code is creating the third tab, which is related to the conversion of the file from its original format to CSV. If the end user is not bothered to create a markdown file and then converting that markdown into CSV. I've created error handling, taking into account the embedding models and the non-embedding models, and then the end user can choose easily whatever model they want and the embedding models that they want. The end user can then upload different formats of the file or files depending on what they want. And then I'm invoking the previous functions that I've created up top in step number 2, where I've created lots of functions for the file processing, invoking the Ollama client functions, invoking the embeddings, invoking the functions related to processing file to question answers, extracting question answer pairs, and so on and so forth. And then the end user can download the full CSV file with embeddings or the CSV file without embeddings, and in both cases the end user can see the question and answer pairs. And I've added some error handling as well, just for the sake of it. And lastly, it's invoking of everything that I've created above and implementing the code. Thanks a lot for watching. Hope you found this video useful and insightful. I've prepared a couple of them other videos about fine-tuning large language models and deploying them to OpenWebUI. I'm going to be putting the links in the description below. You can also pay my website a visit at www.apcmasterypath.co.uk, where I provide multiple packages for the RSS APC candidates to support them throughout their RSCS journey. Also, I provide lots of insights about the RSS APC process, the different areas of competence, and how you can deploy AI within the construction industry. Do not forget to hit the like button and subscribe so that you get notified about our latest videos.